All right, everybody. Welcome to the Impulse Momentum and Collision Lab. And so in this lab, we're going to be using the dynamic cart track again. We're going to be using the motion sensor here set on this end where the feet are set. So you're going to have to set the feet on here to give it some elevation. But you only need to keep the feet at the minimum elevation because that provides enough angle to accelerate the cart just well. And so on this, we got the cart. As you remember, we got the force sensor mounted to the force sensor bracket. This will already be done for you. And in the first instance, in which this case is, we're going to have the rubber bumper mounted to this. And you can see that little black bumper right there. And that is going to be our first set. And so for this video, I'm just going to give you the two extremes. But in this case, we're going to have a magnetic bumper, which you see there. We're going to have a soft spring, a harder spring, and this bumper. And so we're going to use all four of these to get our values with, or to do the experiment with. And so what are we going to do? We're going to have to run this cart down and let it collide into the force sensor, and we're going to monitor its velocity as it does so, and then we're going to measure the force as it hits this bumper over here. And so in this case, each of these runs, and I'll show you again in a minute, but we can see where this is set up at this bottom end of the track, do not exceed 60, because 60 is plenty to give us what we need to see. 60 centimeters it is. Keep the back of the cart at 60 centimeters. And so if we go higher than that, then that just means it's going to come crashing down with more momentum, in which case we don't really need that much because we don't want to damage any of the sensors or anything like that. Okay, we have the Pasco unit over here set up, and you can see that the motion sensor is set up to the digital output, our inputs right there, 1 and 2. Make sure the yellow is in number 1, and the force sensor over there is put into the Passport 1 jack there at the bottom corner. All right, and so in that case, let's go ahead and start. We got to start the program, so let's do that part now. Okay, so what are we going to need to do? We need to kind of come over here. We're going to start the capstone program. All right, so it's detecting our hardware. Let's open that up. Now you can see already that the force sensor is already present and accounted for, but the motion sensor is not. So we got to click on the digital inputs here, and we're going to scroll down until we find motion sensor, which is there. We'll go ahead and click on that, and so now motion sensor is there. All right, so now we have both our sensors set up. Let's go to data summary over here. Let's look at the force. Click on force and click on the cog and numerical format, and we're going to make sure that that's set for 3 decimal places, which it is, so that's good. And let's go to the velocity here under the motion sensor. Click on the cog, numerical format, and make sure that's also set for 3 decimal places. We'll press OK. That's all set up now. We can go ahead and close that. Let's come down here, motion sensor. We're going to bring this up to 100 hertz, and for the high resolution force sensor, we're going to bring this up to 500. And 500 is going to give us an adequate enough points, because this thing, when it hits very quickly, and it spends very little time in contact with the bumper. And so if it spends a little time in contact with the bumper, we need to have a high rate of measurement so that we can collect some data over that time period. All right, so we've got everything set. Now, what you're going to want to do is you're going to want to bring your cart up to 60 centimeters, like I showed you, like it shows here. And then you're going to come over here, and for the we're going to look at motion sensor, and we're going to select this right here, this 0 sensor now setting. And what that's going to do is it's going to set that distance from the motion sensor to the cart at 0. And so then everything else that happens from there will just move away. So it'll initially start at 0. And at the same time, let's go ahead, and while we're doing this, let's go ahead and press this 0 here on the force sensor. All right. So now we've got our sensors calibrated. Everything's calibrated. We just need to bring in 2 graphs. So let's bring in 2 graphs. So we have graph number 1, just double click there. Graph number 2, double click there. And go here, and we're going to, for the first one, we're going to pick force. It'll automatically pick time on the bottom scale. And we're going to come here and we're going to put velocity, and velocity is also going to be as a function of time. So now we have everything set up. All our measurements are set up for their recording rates. All our sensors are set up. Everything's good to go. So now what do we have to do? We actually have to just run our test. And so we're going to bring the cart, as you see here, to 60. We've got that set at 60. And now I'm going to press record. We're going to wait about half a second to a second, and then we'll let go and let it hit the sensor. Now I could have stopped it earlier after the first hit, because really all we're going to care about is this one hit. But the kind of cool part here that we can also see, and we could do some math to figure it out, is there's a dampening feature. In other words, we're losing some of the kinetic energy in this collision, right? Because what we see here is we see this is hitting the sensor, and it's got some momentum as it comes. It hits the sensor and then it recoils off. Well, if everything was conserved in this situation, it would bounce back and come back with the same velocity that it hit it the first time, and it would just keep bouncing, right? It would just keep coming back and forth. But in each case, we see this damped kind of effect where we're losing some of the kinetic energy. So it's hitting at a slower speed, hitting at a slower speed, hitting at a slower speed, hitting at a slower speed. And we could actually use that information to deduce what the dampening effect is, or what energy we're losing from this system as it's continuously bumping into this cart. And in this graph, you can also see, right? You can see the velocity was very high when it hit the first time, wasn't as high the second time, and again, and again, and again, and again, and again. And so you can work out what the dampening effect is. However, that is not important for this lab. I just wanted to show you that cool little bit of physics. In this lab, we're only caring about this first initial impact, right? This first initial impact, which we see there, and this first initial impact represented here in the velocity graph as our maximum velocity when it hit, and then it slows down very quickly, comes to a stop, accelerates back the other way, right? So it gets pushed off and starts traveling back the other way, and then that starts to slow down, come to a stop, and start heading back, and then it hits the sensor again, and so on and so forth. So we only care about this part really where the impact is happening, which is this drastic change, this almost vertical line that you see here. That should correlate in time with this impact that we see over here. So let's just move the graph just a little bit so we have that highlighted. I'm going to bring out the highlighter tool, which is up here in this corner. And I'm going to highlight just this first area here. And I'm going to click this button here to scale everything accordingly. Oh, that didn't work. So if that happens, you can use you can set this accordingly. You can drag the graph and then use the bars here to adjust your graph manually, which is what I'm doing. So I'm going to set that over there, because really I want this to kind of show up as a kind of large thing so I can see. But I need to scroll out a little bit so I can grab this window and make it much smaller. Now I'm going to scroll back in. Oops. Okay. So what do we need to do here? We need to highlight everywhere where the impact is actually happening. And so we can see where it starts, and we want to include that first starting one right there. I'm going to go ahead and elongate this just a little bit more so you can see a little more clearly, right? So you can see the measurements right there. And this one is the one where it first collides with or it's getting ready to collide with the sensor. And then we need to move this one over. And so realistically, the one that's on the other side there is where this collision stops happening. This is kind of a cool little information. This is the vibrational part of the actual force sensor itself. So when you think about something colliding with something else, right, it's a right kind of a thing. And so that is kind of related to that. So kind of ignore this noise right here because that'll come back to zero very quickly. And so this is the part we care about. And so in this particular case, what do we need to know? Well, we need to know the amount, the area under this curve. And so since we've got this highlighted now, you can come up here and you can see the what is it, 1, 2, 3, 4, 5, 6 button along on the graph actually gives you that area under the curve. That symbol represents like a curve, and then the area is shaded in underneath. So let's click that. And now that'll give you the area under the curve. And so now you can see the area under the curve is newtons per second. That's what we have under there. And so that is the impact, right? Because we know the impulse is force times time. Or force over some amount of time, right? So it's that how long was it in contact applying that force, and that is our impulse, which is also equal to our change in momentum, which we'll look at on the other graph in just a second. But so we have that, but we also need to know what the mean force was. And so in that case, let's come up here and let's make sure that mean is checked, which it is. And so we'll come out of that, and let's click on the summation sign, and that'll give us our mean force. All right. So in this case, we're going to use what? So we're going to put this number in. We're going to input this for I area. And this one we're going to put for the force average. And so those are our two values that we're going to take out of here, as well as we need the time that this collision starts and the time that it ends. And so I'm going to put a coordinate tool here. I'm going to move it down to this first point where we started measuring from. And so our collision should begin somewhere right around 2.024 seconds. So that's going to be your time initial that this impact happens. And then we're going to go to over here, and we're going to see the time that it stops happening, and that's 0.046 seconds. And so you can see that's quite a very quick amount of time, or a very short amount of time, that the whole of this impact took place. Right? 0.0 something seconds. And so, and we'll determine that in a minute, but we've got our time beginning, time ending. That time should correlate to this change that you see here on the velocity graph. Should correlate to this part right here that's in changing. And so what I'm going to do is I'm just going to go ahead and change this, move this around so that I have this kind of centered in my screen. And you see what I'm doing there. I'm just grabbing the axis, and you see the two little arrows show up there, and then you can just click and hold and drag that thing along. And so now if I take a coordinate tool, and I add a coordinate, and I go up here to the top. All right, so one of these two is really where we started this collision from. So that's at 2 seconds. This is at 2.01 seconds. And if you look, this is at 0.02 seconds. So it happened somewhere in the middle here. And so the rate that we were recording with the motion sensor was much slower than the rate we were recording of this, because you can't record that high. But so let's start with this time here, and then this time here should more or less correlate with when it was leaving, 2.06, which our leaving time was 2.04, so maybe it's this one. That's close enough, because it's 4.6, that's 5. All right, so we have our two pieces. So now we know what part to highlight. Let's go ahead and bring a highlighting box in. I'm going to highlight from there, and I'm going to include that point there. And so now we can do what? Now we can sit here, we can go up here, we can click on maximum and minimum, add that to the graph. And then we're going to click on that, and it's going to give us our max, our minimum velocity, and our mean velocity. So what do we need out of that? We need this maximum, which is 0.54, this is our initial velocity as it's hitting the sensor. And we need this one, which is our velocity or our minimum velocity as it's leaving the sensor, or our V final. So our V initial, our V final, and that gives us all the pieces of information that we need from the graph. The rest we actually calculate. So we know the velocity, we know the mass of the cart, and we can determine what the actual momentum was coming in and the momentum was leaving. And with that being said, now you have all the information. From this graph, we need to change the bumper to the spring or whatever one you're doing next, and then do each individual run to fill out the table for each one. And so let's just do the polar opposites. We went from that, so I'm going to do the light spring, and we'll see what that looks like so we can compare the two. All right, so I've set up the soft spring for number 2, which you see there. It's nice and tight. I'm going to tear this again because the mass of this thing is not going to be the same as the bumper. I'm going to bring our cart up to 60 again, just where we were before. I don't have to change the motion sensor because we're at the same distance away. And what I'm going to do, I'm just going to start recording another run, and we just leave all this information here. So I'm going to start recording another run, and then we're going to let it go just like we did before. Okay. Now, what I want you to notice here is I want you to notice that it does not dampen. So we were talking about the dampening effect that the bumper had. This does not dampen as much as the other one did. In other words, it's going on for quite a while longer. It's hitting again with almost the same amount of velocity as it was before. In other words, the spring has changed the way that this system is operating. The energy lost in this spring is not as much. And so we can figure out the dampening effect as well here. But again, that's not the reason for this lab. This lab is to talk about the impulse. And so we're going to do the exact same thing again. We're going to highlight the one region that we're trying to find, which is this first set of, what do you call it? I want to show you something else real quick because we mentioned it on the last run. And I said to you that things will vibrate as they get hit. And so now we see that it strikes the spring, and then it comes and it leaves the spring. And look at this little oscillation pattern down here. This oscillation pattern is the spring vibrating. The spring is going, you like that noise? And so what you see there is the actual force sensor is measuring the spring vibration that happened from the collision. And so you can actually measure that as well here, but we don't need that either. What we want to look at is we want to look at this area right here, because that's what we need to see. And so I'm just going to bring this around a little bit. I'm going to elongate that out a little bit. And I'm going to go ahead and highlight this area. And we can see exactly where this is starting. And we can see where this is ending. And so now we can find the area under the curve. Right there is given by that. Now, that'll be your area under the curve, which you'll place in your table, just like before. You do the same exact thing again. You'll find your initial time, your start time. So let's go ahead and I'll just go ahead and add 2 coordinate tools. Oops. Add a coordinate tool. I'll put it there. We'll add another coordinate tool. We'll put it there. And so now you know your start time, your final time, and we need to add the mean. So that's already checked. So let's add the mean, and there you go. So now you have your average force, you have your area under the curve, which is your impulse, or which is equal to your impulse. You have your start time and your final time, which should equate to the times that this over here, this change in velocity starts happening. So let's go ahead and address this side. So we need to move this around so we can highlight all that. All right, much smoother curve. A lot more data points in there. All right, so we need to go from 1.76 seconds, wherever that happens to be. Let's go ahead and add a coordinate tool. 1.76, that's this one right there. Alright, so that's that one. I'll just add another coordinate tool so you can see where the other one is. The other one is down here. It should be at 1.88, which is this one. Alright, so now we have the 2. There's our 2 points, and we can highlight we can see where, we don't even need to highlight it because it shows up on here. We have our maximum velocity coming in, and we have our velocity going out. So we have V initial, V final. And so now we have all the information that we need to know. But one of the cool things I want to show you is, so here we have run 2 that I did with the spring. And here's the one that I did with the bumper. As we discussed in class, we talked about lowering that force that you feel during, remember we talked about the auto accident. And so the whole idea of the crumple zones and the airbags and all that kind of stuff was to elongate the time so that the maximum force would come down, because the area under the curve was set, if you remember, by the what? By the momentum that was generated from the cart. The cart has a specific mass. The cart has a specific velocity, which is the same in all these different collisions. The only thing that's changing is the amount of time that it's in contact with the thing that it collides with and recoils back. And so to change that direction in a very quick manner, which the bumper does, we see the maximum force is huge, almost 35-ish newtons, right? And these scales are the same now, and you can see, okay, 35 newtons, where's 35 newtons over here? Way over here. And this one is what? Way, way lower than that one. And so if we kind of zoom this in and we go from like 0 to 4 seconds here, and I'll do the same thing here, 4 seconds, you can see this one is much wider than this one. Maybe I'll even take this back to like 1 second so that you get even more of we'll do a 2 second interval around there. So this is a 2 second interval now. You can see that the time it takes is quite long compared to if I make this a 2 second interval. I start at 1 and we go to 3. There you go. So now you can see over a 2 second interval, the time that it was in contact with the spring and slowing down is much, much shorter than the time that it took the bumper to turn it around. However, the area under the curve, again, these areas should be extremely similar in this measurement, because the impulse is set by the change in momentum, and the change in momentum is the velocity of the cart, which is the same, and the mass of the cart, which is the same, so it's set. The system has already been set by the cart. And so I just wanted to illustrate the differences in these two force curves that we see here. All right, with that being said, you should be able to easily fill out your table, and once you fill out your table, you can do the calculations very easily, and that's that. So I will see you in class.